Hi everyone, today we are going to be talking about Chapter 14, Non-Experimental Quantitative Research. This is our last chapter on quantitative design and a very important method in educational research. So what is non-experimental research and how does it compare to the other types of experimental research that we've covered, including experimental research and quasi-experimental research? Well, non-experimental research is methods when it is not possible for either ethical reasons or logistical reasons to manipulate the independent variable. So sometimes it's impossible, sometimes it's unethical. And so researchers use a non-experimental design to examine that topic in those cases. So the example that you will see at the start of the chapter in the vignette is about the link between smoking and lung cancer. And they talk about the large body of research that went into finding a causal relationship between these two variables, and also used it as an example of how it would be unethical to make a experimental group that was given the treatment of smoking, of course, for ethical reasons, and so why they had to use non-experimental research. And so there are a lot of instances like this in education. And so there are some particular design considerations that researchers need to make when they are in situations where they are using non-experimental design. So the steps for non-experimental research are similar to other quantitative or confirmatory or top-down approaches where you are testing a hypothesis. So the first step is to define your research problem and your hypothesis. Next, you will select your variables, define your variables, which one is your independent variable, what is your dependent variable. Then you will collect your data, analyze the data, and interpret the results. And so one of the main considerations and factors in non-experimental research is to avoid the post hoc fallacy, being that correlation does not equate to causation. And this is something that we've been talking about a lot. And in this chapter, you will also see some of the particular considerations for non-experimental design. So this post hoc fallacy is the idea that just because something happens before another, and so there's this relationship, that doesn't mean that the first thing caused the latter. So an example might be if you get sick, you might assume that it came from your friend's child who came to visit you yesterday because they were sick too. So there's a relationship between that, but just because of that, that doesn't prove causation. So when you are thinking about or analyzing or proposing non-experimental research, the key issue centers around the contours of the independent variable. So in non-experimental design, it's different from quasi-experimental and experimental design where they manipulate the independent variable in that it cannot be manipulated. So there's lots of reasons why. And so some of these variables that cannot be manipulated, some of them might be categorical variables like biological sex, ethnicity, grade retention, smoking status, and others might be quantitative like GPA, age, intelligence, socioeconomic status. So some of these variables cannot be manipulated. And so even though they can't be manipulated, they might be of importance in education. So one thing to look out for when we read about experimental design, we read about weak design and quasi design being stronger, and then what you need for the strongest design. So since you cannot have manipulation in non-experimental research, you're not able to randomly assign participants to a control group or an experimental group because that would involve manipulation. So sometimes there are controls, however, it's not something where you could use random assignment. So a simple case would be correlational research in a lot of ways that oftentimes can lack some of the necessary controls to have a strong design. So an example that you'll read in the text is the correlation between biological sex and math performance, and all of the potential other factors that might be leading to this relationship. And so they also looked at motivation and math performance, and again, used correlation analysis, but talked about all of the other factors that were contributing to the relationship that they saw. And because there were other factors, it's impossible to isolate one variable as causing the other. And so just like we've talked about in other chapters, in non-experimental research, there are the same 3 required conditions for causation. This relationship condition, that one variable must be related to the other, temporal order, the independent variable must come before, and then no confounding variables. You can't have an alternative explanation. So let's talk about these 3 different causes and how they look in experimental design versus non-experimental design. So the first check that you need to look for when you are looking for a causal relationship is that the variables must have a relationship. The cause must covary with the effect. So in experimental research, you're able to establish this by comparing groups with your treatment group, your control group, experimental group, and your control group. But in non-experimental design, you cannot have random assignment to those groups, so you have to establish that relationship through correlation. However, that leads to what I talked about a little bit on the last slide, the third variable problem. So we'll talk about some ways to address that. Now, the cause must precede the effect. This is definitely challenging to establish in some non-experimental designs. So in experimental research, since the researcher is manipulating the independent variable, they're able to ensure that it comes first. But since that manipulation is not possible in non-experimental design, there's not always an easy way to ensure that the independent variable is coming first. So one way to address this is by the time mode of the design, such as a longitudinal study where you can track changes over time, and that can establish and collect more evidence to show that that cause is preceding the effect. And then lastly, and we talked about this in experimental and quasi-experimental design as well, is there cannot be any rival hypotheses or alternative explanations, have to be implausible. And so some of the ways that, so in experimental research, you can use random assignment to the groups to try to balance for confounding factors, and some of the other methods that we talked about as well. And in non-experimental research, it's also important that controls are built into the design to make sure that researchers are controlling for potentially confounding variables. So similar to some of the other controls we talked about in non-experimental design, oftentimes researchers use matching or statistical controls, a regression if it's quantitative variables, ANCOVA if it is qualitative or categorical variables, or even holding those extraneous variables constant. So thinking about that third variable problem in the text, there's quite a few examples of the third variable problem, and we've shared a couple examples of these. You might have more examples to share today as well, but this is when another factor is causing both A and B. So there is a relationship between the variables, but the identified variables are not causing each other, something else actually is. So the example in the text was fire trucks and fire damage. There's a positive correlation between more fire trucks and more fire damage. However, more trucks are not causing more fire damage. Instead, it's the fire size that is causing both of these effects. So if you think back to the visuals that we've looked at to look at correlation. You can imagine the relationship between these variables, but actually there's the third variable underneath that's actually controlling both of those. And so again, some of those controls that I talked about on the last slide, it's important to control for potentially confounding variables, since especially you're not able to manipulate and you're not able to randomly assign participants to a group because of that lack of manipulation. So when designing non-experimental research, there are two dimensions to consider. One is the time dimension, and then the other is related to the overall purpose. So in thinking about time, there's some benefits and some weaknesses to different time approaches. So one is cross-sectional research. This is when the data are collected at a single point in time. So obviously this would be quick, efficient. However, this brings into question the second requirement for causal relationships, because since you are just collecting the data once at a static period of time, it can be harder to establish this time relationship. So but it does provide a snapshot of variables, and it can be useful in a lot of settings. Then we have longitudinal research, where the data are collected from the same participants over a long period of time. So you have multiple different data points. And this might remind you of some of the sequencing and the different designs in experimental research. And this is better at establishing causal relationships because you have more evidence of the independent variable preceding the dependent variable. However, there are some threats to validity with longitudinal research. It can be more costly, it can be more challenging, and then also you can have differential attrition where participants drop out, and perhaps the participants that drop out significantly change the scope of the data that are collected. And so there are some threats there. Then we have retrospective research, where data are collected at a moment in time. However, the participant is producing or reporting retrospective data as well. And so this can be really useful when you are looking at something rare and maybe it's more challenging to sample and find participants currently undergoing this phenomenon. So it can help you with that. However, there are some threats in terms of perhaps there might be a bias with the participant correctly remembering. There's a lot of research about that. However, in some instances, it's more efficient to do retrospective research than wait for it to come again. And so you can think of things like political events, or maybe even natural disasters or something like that, that you wouldn't want to just wait for it to happen again. And so you might want to do retrospective research to look at that, something like the pandemic, or it could be something related to a health outcome or something like that. And then the other dimension has to do with the research objective or the research purpose. And so this goes back to the beginning chapters talking about the different purposes for educational research. And when you write a research proposal, in your introduction to your research proposal, you want to talk about your research purpose. So some of the language in this chapter might serve helpful for you if you are thinking about one of these designs or quantitative research in general, to think about how you could align your proposal with a research objective or purpose. So the three research purposes associated with non-experimental design are descriptive, predictive, and explanatory. So descriptive research is really useful, and particularly if you have that cross-sectional research and the other types as well, but it provides a snapshot of an existing condition or phenomenon to show the relationship between variables without manipulating them. So for instance, descriptive research might analyze school dropout rates by gender to understand if there's a relationship there. Then we have predictive research, which identifies a relationship between variables. for the purpose of predicting what will likely happen in the future. So this is focused on, and we'll learn about some of the analysis that you can do to carry out some of these goals and analyze the data, but it analyzes the patterns between those relationships to predict and anticipate what might happen later. So a classic example of that is high school GPA predicting college performance, or standardized test scores like SAT predicting college performance, or the GRE and performance in graduate studies. So there are studies that look at those relationships. And then finally, explanatory research. This type of research is testing causal hypotheses to understand if the independent variable is causing the latter. And so this can help you understand if there is a causal relationship, and then understand why those relationships exist. Is it a causal relationship? Is it something else? For instance, how grade retention affects academic achievement. So the cause there would be retention, and then the effect would be the outcomes on academic achievement. So I am wondering what examples you can think of in education where non-experimental design would be a really useful design, because independent manipulation of the independent variable would be either unethical or implausible. However, it would still be an important research topic. So that is the key point when it comes to non-experimental research as opposed to experimental or quasi-experimental, is that independent variable, due to the nature of it, you cannot manipulate it. And so just as in other designs, having control methods are very important to make sure that there is not an extraneous variable that's affecting it. And if the researchers are hoping to establish a causal relationship, they have to ensure that they have evidence of each of those three elements that are necessary to demonstrate a causal relationship. And then keep in mind the dimensions, both the time dimensions, cross-sectional, longitudinal, or retrospective, and then the overall study objectives or study purposes, descriptive, predictive, or explanatory. So what are your ideas and your thoughts and examples of research questions that would be best served with non-experimental research? And I wanted to leave you with an example of non-experimental research. So here you can see the design. You can think about the independent variable, the dependent variable, and then why was this non-experimental design? What was it about the independent variable that made it not being able to be manipulated? And what you think about the overall design, any validity issues you notice, questions you have about the design, and what you think about the findings.
We find a big difference between people who played Pokemon in their childhood versus those who didn't. And so those people who are Pokemon experts not only develop a unique brain representation for Pokemon and visual cortex, but the most interesting part to us is that the location of that response to Pokemon is consistent across people.
It's a great mystery. How does experience contribute to shaping the brain? And this really is an opportunity to use a unique stimulus and a very intense experience during childhood. Second of all, because Pokemon game used a handheld device, you're limited by the length of your hands, really. It provided kind of a natural experiment, but was a somewhat controlled setting.
The people we were looking to scan played a lot of Pokemon in their childhood, so somewhere between 1995 and 1998, they were 5 and 8 years old. These are subjects who can name hundreds of Pokemon, and they have almost lifelong visual experience beginning in childhood with Pokemon. And then the other group of people that we were looking for were people that were the exact opposite. They never played Pokemon, they know nothing about it.
We put them in an fMRI scanner and then show them different kinds of stimuli. So they'll see common stimuli such as faces or places or words or objects, and also they'll be seeing Pokemon stimuli.
The Pokemon region that we observed, it was in high-level visual cortex, the part of the brain that's involved in recognizing things like words and faces. It helps us pinpoint which theory of brain organization might be the most responsible for determining how your visual cortex develops from childhood to adulthood.
basically looking at them at the central vision, and because they're really small, place them in a particular fold of the brain that we know gets input from the central part of your retina or central vision.
So if you look at Pokemon, they're very small and you use your central vision, so they land in a part of the center of your retina, whereas stimuli like this room, for example, go to the periphery of your retina. And so because they have different locations on your retina, they have different locations in your brain. And it turns out that the Pokemon region emerges in a part of your brain that responds to information from the center of your retina. And so that finding suggests that the very way that you look at a visual stimulus, like a Pokemon or words, determines why your brain is organized the way it is. And that's useful going forward because it might suggest that visual deficits like dyslexia or face blindness might result simply from the way you look at stimuli. And so it's a promising future avenue.
Okay, so I am anxious to hear your thoughts and your other ideas and questions about non-experimental design.